Hey students, how are you? Well, today we will be talking about chapters, sections 14.1 and point 2, and it's about radicals. Radicals. That word right there is talking about square roots. Well, that's this sign here. That's the radical sign. Okay, so it's the word. This word is not to be confused with rational. The word rational, as in rational expressions, because that means fractions, basically. In this case, we will be talking about radicals, and more specifically square roots. Even though we don't write the index here, we always assume it's 2 if we don't write it. So yeah, we're going to be talking about square roots in these sections, and you need to memorize this name here, radical, and remember that it's not to be confused with the word rational. Alright, so let's go ahead and start with section 8. Oh, and by the way, this is basically the lesson for these 2 sections. So if you if for any reason you fall behind, you can't come to class, go ahead and use this this video as a lesson and to catch up. Okay, and we should you should be able to do your assignment after going through these sections, through this video. What else? I wanted to say something else. Hold on. Let's see what else. I forgot about. Let's see. If you yeah, no, well, let's do it this way. Let's do it this way. That's what I want to talk about. Let's do it this way from now to the end of the semester, and let's go ahead and let me work out some lessons like before you come to class, and this way you can watch the video and before you come to class, just as though you were reading. See, because I realized that you guys don't have time to read. By this time it is obvious. You don't read before the class, even though I wanted you to do that. But in this, if you can watch this video before you come to class, that would count as reading, basically, and you would be ready for the class. In the classroom, face-to-face class. There we would work on examples or problems. So instead of having a class, we would I would test you and see if you know most of this stuff. If you don't, I will know it and I will correct you, and you can memorize and learn at the same time. So I think that's a good plan. So yeah, I'm gonna continue making these videos, and you view those before you come to class, and then in class we just practice a lot. Okay, which is what I wanted to do in the first place. That's why I wanted you to read the book first. Oh, and by the way, we are gonna go from the book. In this way, I don't have to prepare a class. I don't have to put it in the computer. In this way, I just I save time to make the videos. See what I'm saying? And it also allows us to use the book, the ebook, which is this book basically, online. And remember to go to your library media, and you're gonna find the book in there. Just click on the section, the right sections, and check book and textbook, and then click enter, and it should pop up on your screen. In that way, we can use the book from the software, and also, well, the software itself, which tests your ability to do the problems. Okay, so let's do it this way from now on. I'm not the rest of the semester, which is not long. Just we will have only have 3 weeks, 3.5 maybe. All right, so let's go ahead and start here really quick, because and these two lessons are not very difficult lessons. I believe you saw this in high school. I'm just gonna go through, do a review through this. A review about square roots and how to multiply square roots, which is section 4.2. That's what section 14.2 talks about. And so let's go ahead and start with section 14.1, which is an introduction to the radical expressions. Memorize that. Whatever I highlight, go ahead and memorize it before you come to class. And I'm in section A, square roots. Again, the radical sign for square roots is this. That's the radical sign. That's the radical sign. Because we don't have an index here, we assume it is 2. Okay, so this is the square root of 225. Okay. All right. You don't have to know these two words. The same with radical sign. Yeah, well, you have to know that, of course, but I already highlighted that up there. Oh, and I want to point out that from now on, think about the base of any power, the base as being the square root. Let me show you what I mean. Well, let's say I have a number 36, and that is the same thing as 6 squared, right? So if you ask me what is the square root of 36, I would say it is 6, right? Because 6 times 6 is 36. Yeah. And basically, when they ask you for the square root, they are asking you for a number that when multiplied by itself gives you that value inside the radical sign. Okay. And in this case, the square root of 36, we know that is 6. We know that from high school. Okay. And then, since I'm writing this 36, since I know I can write this 36 as 6 squared, and I just said that this 6 is a square root of 36. Well, this is the same number as that, so you can think of this base whenever you have an exponent like this. Yeah, power like this, you think of the base as being the square root. Okay, base as being the square root. So this C here is the square root of 6 squared. This 6 here is the square root of 6 squared. All right. So from now on, identify the base as the square root, if you can remember that. I'm not going to test you on it, but it would be nice if you remember that. So square root of means that C right there. All right, and that's and we said that this sign is the radical sign. So the number inside is called the radicand. And we will come to it in a different section there, in a different objective. And so this is called the radicand. Okay, this sign is called the radical again. Okay, that's all you have to remember there, because I need to know that, that when I talk about the radicand, that you know exactly what I mean. Okay, if I'm talking about the radical, that you know exactly what I mean. Okay, so know those two words before you come to class. Let's see what else. In this case, and you don't have to know this word, whenever they're talking about the principal root, they're talking about the square root. Like in high school, when they ask for the square root of 25, yeah, square root of 25, we always gave the teacher a positive answer. Okay, and even though technically you have two answers, like a positive and a negative value for the answer, because the square root of positive 5 is 25, and the negative negative square root of 5 is the square root of negative 5 is 25. So the square root of positive 5 and the square root of negative 5 is also 25. It's 25. Okay, so you technically have two answers. So when they're talking about the principal square root, they will be talking about just one answer, and it's going to be the positive answer. In these sections, we will assume that we're talking about the principal square root. Okay, and I will get to it. I will remind you whenever I get to it. And you do not have to know this word. If you don't have to. I'm not going to test you on it. But remember that if they ask you specifically for roots, that's going to mean give the two answers, a positive and negative answer of the roots. In this case, to find the square root of 81, you need to find the positive and the negative answer. Okay, but just think about the question. Okay, in this case, they did ask you for both of them, because roots here is plural, so they ask you for two answers, the positive and the negative answer. But more than likely, they're going to ask you for the positive answer in most problems. Let's see what else. See, for example, here, find the square root of 225. They didn't ask you to find both roots. Okay, so you only find the positive one. Okay, here you're still finding the positive square roots, but the square root, and then just add the sign, because the sign is outside the radical sign there. Okay, so don't get confused there. This negative sign is not inside, so they're asking you, still asking you for the positive root, which is 8, and then just add the sign at the end. Okay, this sign comes from out here. All right, so don't get confused by that. All right, let me move the book. All right, so now we're here. I guess we're done with section 8, objective A. So let's go ahead and work out some problems from objective A real quick, just so we know what you'll be expecting on your assignment. And let me just focus here. There. Okay, so if they ask us to find the square roots, again they're talking about two roots specifically, the positive and the negative one. So the square root of 4 would be 2 and negative 2. Square root of 1 would be 1 and negative 1. Square root of 9 would be 3 and negative 3. And the square root of 16 would be 4 and negative 4. Square root of 10 would be 10 and negative 10. And so on, okay? And here, if you want to use your calculator, it's fine. I mean, I can't stop you because you are allowed to use them. So, but if you can do it in your head, that would be nice. Okay. Okay. So here we need to simplify. They're asking you for the square root of 4. Okay. Again, here they are not asking you for 2 roots. They're only asking you to simplify it. That means we assume that they're asking you for the positive roots. So the square root of 2 is, 4 is 2. Square root of 1 is 1. Negative square root of 9 is 3. And then just add the sign. So don't miss the sign. Yeah, but the sign is added to at the end there. Same thing for this. Square root of 25 is 5. Then just add the sign. Square root of 36 is 6. Then just add the sign at the end. In these two sections, we will not talk about negative values inside the radical sign or negative radicands. Okay, because that's going to yield imaginary numbers, and we are not working on imaginary numbers in these sections, in this chapter actually. So that's all the examples there, that all the variations there, I think, that you may come across on your assignment. So let's move back to section objective B, which is approximating square roots. Okay. Oh, no, not this section. No, because we want to skip this section because it talks about approximating square roots with your calculator. Now that's, you can do that. I mean, you can do that on your own, you know, if you want to practice. I mean, how difficult is to use this the radical, button? That yeah, I know you can do it on your own if you want to practice that. So I'm gonna skip that and move on to to objective C. Applications of square roots. Applications of square roots. I might give you a problem like this, but I might not, because see, all the problems that involve some kind of application with radicals, they're gonna give you the equation. So that's not a challenge. All it is just substituting, substituting the values they give you into the equation they give you. So that's not much of a challenge, that's very, very basic. So I'm gonna skip that too. Okay, and if I do include one of those problems, don't worry about those, because you will see exactly what to do once you read the question. Okay. All right, so let's move on to D. Radicands and radical expressions. Okay. And remember that I'm going by the book. Okay, this is the section from the book, so you can make prints out of your book somehow. It's not gonna let you print, but you can make prints from print screen. You can print your screen and put it on a Word document and print from there. That's how I do it. How I would do it. In this case, okay, so let's go ahead and talk about radicands and radical expressions. Okay, so now they are introducing variables. In other words, expressions, radical expressions, and that's gonna be the name of the technical name of it, radical expressions. Okay, radicands and radical expressions. And here they give us a few examples. Okay. Square root of 14, square root of x, 8 times square root of x squared plus 4, and then square root of x squared minus 5 of 5. Notice that here, this is just one expression. The whole thing is one expression, okay? You cannot, well, when we talk about multiplication, you won't be able to separate these two because this is an addition here. This is not a multiplication. And I will remind you about this on the next section. Okay, so let's move on there. Okay, so you want to have questions like this in the assignment. Identify the radicand in each expression, and that just to warm you up. Okay, so I might give you one or two. The radicand, again, just to make you practice this word radicand, that means the number or the expression inside the box, just the expression inside the box. Okay, everything else is not gonna be included in this case. 105 is inside the box, therefore that's the radicand. X is inside the box, so that's the radicand. X plus 2 is inside the radical, therefore x plus 2 is the radicand. And in this case, y squared minus 5 is inside the radical sign, so y squared minus 5 is the radicand. In this case, the whole thing is a minus b over a plus b is inside the radical sign, therefore the radicand is the whole thing. Alright, I might give you a problem or two like that, and I don't think we need to go over that unless they have some variation of that here in the problems. Let me see. Well, I guess I should point out that the radicand doesn't include the positive 9 here. I mean the positive 8. The radicand doesn't include this ab squared. The radicand doesn't include the x squared y here. Neither it's included in the negative 4 is included. The radicand there. Negative 9 is not included in there, and 5 is not included in there. Okay, so just to be very specific. All right, so let's go back to section E. Like I said, this is just a review of the rules for radicals. E, expressions that are meaningful as real numbers. That's the title of that. All that means is that you need to remember that we do not want negative values, negative radicands, negative values inside the radical sign, negative radicands. Okay, because then you're gonna get an imaginary value, and we are not prepared for that yet. We will later on, but not for these few sections. Okay, so just remember that. So let's go ahead and work out a few problems here from section E. And oops, right there. So they're going to ask you questions like, determine whether each expression represents a real number. Right, yes or no? Okay. Do all of these expressions, do they represent a real number? Well, only if they are positive. The radicands are positive. In this case, it is. This one is not. This one is not. This one is. Okay. Notice that the negative sign is outside the radical sign. So this one is a real number because the radicand is positive. This one is also. This one is not. See, the radicand is negative. This one, though, you have two negative signs together. Think about it as multiplication, multiplying two different signs, or -1 times -49. That's gonna give you a positive answer. So the radicand is positive. Therefore, this is a real number. All right. So don't let that trick you. Think about the signs. Okay. All right. That's section E in a nutshell. Yeah. So let's move on to Section objective F. Perfect square radicands. Perfect square radicands. They are introducing this because we are gonna use this pretty much a lot when we work with expressions. Because remember that in expressions, whenever you have expressions, you can have perfect squares, and then we used to factor them out. In this case, that's sort of what we do. That's sort of what we will be doing, because if you can get a perfect square inside the radical sign, you can bring it outside. Okay, so just like this x squared, you can bring it outside as x. This, in this case, x equals 3 squared. That is a perfect square. You can bring it outside because remember that the index here is 2, the power is 2. That's why you can bring this 3 outside the radical sign there. Okay, and yeah, if you square 3 to the power 2, then that's 9. The square root of 9 is 3, which we already knew. So yeah, and this is the reason why, because of this power of 2 and this index of 2. Okay, and in this, again, in these few sections, we're gonna be using indexes of 2 here. Okay, nothing greater than that. Okay. Well, think about this as being -3 now, because remember that now we're working with variables. Therefore, the answer could be any value. That means a positive or a negative value. Okay, and here they are pointing that out just to let us know that since we are gonna square it, we are gonna end up with a positive answer. See, because even though we do have a negative sign inside the radical sign, which we said would give you an imaginary number, in this case it doesn't, because you are raising the -3 to power 2, and a -3 times a -3 is a +9. Okay, so they're pointing that out, and you don't have to worry about writing the absolute value sign in your answers for these sections. Just remember that if you have a negative sign inside the radical sign, as long as it is squared, then the answer is still positive. Okay, so you still have a positive radicand. Okay, so you shouldn't get imaginary values. Okay, just watch out for this parenthesis. That's the only thing I would add, because sometimes you're gonna have this, well, you should have those parentheses, but sometimes they don't include them, so that means the power of 2 is only affecting the 3, so then you are gonna get a negative answer. Okay, so watch out for this parenthesis right here. All right, so don't worry about the absolute value here. I know if you go through the book, then you're gonna read about this, and just don't worry about it. Not for these sections anyway, and you can worry about it in the algebra class, but not for these sections. Okay, so let's go ahead and work some of this out here, some of these problems. So you may have questions like this, where you have perfect squares as radicands. So remember that even if they are positive or negative, they will be real numbers. Okay. So in this case, you can bring the 10 outside because that 10 is positive. Here you can bring that a 7 outside because this negative is gonna turn into a positive because of this power 2. So yeah, so basically the absolute value, but you don't have to insert this as the absolute value of -7. Okay, just write 7. Then 3x, you can bring it outside because of this power 2, and this a squared, bring it outside. This b squared, bring it outside because they are perfect squares. In this case, watch out for this part right here because the whole thing is one expression. Okay, with 1, 2, 3 in 3 different terms. 1, 2, 3 different terms. The whole thing is one expression. Here, the whole thing was one expression, but we only had one term. Okay, and remember that terms are separated by additions or subtractions. Okay, and in this case, you cannot bring out the x to the outside because now you're adding. Okay, the reason we were able to bring this a squared was because we were multiplying here. Okay, here we are adding, so the whole thing is one expression. You cannot bring the x outside. No, you're gonna have to use either of the two rules. Well, remember to simplify first. As always, ask yourself, whenever you have an expression with more than one term, always ask yourself if all the terms in your expression have common factors. Okay, if you don't, then just move on to using one of the methods we learned for factoring. Okay, so whenever you have expressions with more than one term, simplify it first by looking at all the terms and see if they have factors in common. In this case, they don't. See, because you have an x here, no x here. You have a constant here, but no constant here. Okay, so in this case, you can't simplify this. Okay, so you're gonna have to move on to using one of those methods we use. In this case, it's gonna be this is gonna be a perfect square. So the answer is gonna be, well, it's gonna look like x plus 1 times x plus 1. Okay, or in other words, x plus 1 square. And we will write it like this, just so that we can see that there's a power 2 here, there's an index 2 here. Therefore, now you can bring this x plus 1 outside. Okay, x plus 1. Okay, and again, you don't have to write the absolute value if you don't want to. Not for me anyway. But just remember that it is there because if we have a negative, any negative values for x, then the answer is going to be the expression is going to be negative, and we don't want negative radicands. Okay, or else that's going to give you imaginary numbers. So for these sections, the book is only going to think about the values for x as being positive. Okay, that's why you don't need to include the absolute value signs. Okay, so again, so think about this. If this was a negative 2, the x, then plus 1, that would be negative 1. So the expression will be negative 1. So you will have a radicand, a negative radicand, and this will be an imaginary number. So for all negative values inside the for all negative values of x inside the radical sign, you're gonna have imaginary numbers. Okay, so so the book is only gonna assume that we're gonna be using positive values for the variables. just for these 3 sections, that's all. Okay, let's see if we have any. Let's see here, what else do they have? A square, regular numbers, that's another regular number. Okay, now principal square root of a square. No, it's not telling you much. Principal square roots. This is just telling you to use the positive value. Remember, principal square root means just a positive value. Yeah. So that's all this is telling you. Okay, so don't worry about that. Let's see if they have anything new here. Simplify. Assume that radicands do not represent a square of negative value. See, this is what I've been telling you. Assume that radicands, as in this x here, do not represent the square of a negative number. Okay, do not represent the square of a negative number. Okay, so yeah, from now on, just just assume that all the values of x are going to be positive. Okay, even though you can have negative values too. All right, so in this case, the square root of 3x squared would be 3x. Okay, in this case, the square root of a squared times b squared, you can think about it as being a times b squared. Okay, so the square root of ab squared would be ab. Here again, don't make the mistake of factoring this one first, moving it outside, because you have a whole expression here, just one expression in 3 different terms. All right, factor it out first. You're gonna get x plus 1 squared. Now you're able to move it outside. Okay, so you see how we didn't use absolute values, because we're assuming that we're only using the positive values. Okay, I think that's all. Yeah, this is exactly what I told you. Okay, and let's see if we have any examples, any problems for us. Remember to assume the radicands to not represent. See, in problems for section F here, look at the question again, and it's telling you simplify. Remember that we have assumed that radicands do not represent the square of a negative number. Okay, even though they do. Okay, but not for these sections anyway. And yeah, I know I'm repeating that because that's because it's important. Okay, so here c squared, the square root of c squared is c. Let's see if they have anything. Well, here they have a variation, because now you need to think about that 9 as being 3 squared. If you have a 3 squared, then you can bring it outside. So the answer will be 3x. Here, turn that 16 and into a perfect square, which is 4 squared. Bring it outside as 4, and y squared also. So the answer is 4y there. Let's see if any other variations. No. Well, here bring the whole thing outside, because the whole thing is affected by the 2 there, with power 2. Same thing here, same thing here. Let's move on to this side over here. This shouldn't be that difficult, I don't think. Okay, not a difficult section. All right, and let's see. Okay. Any other variations? No, because see, this includes everything there, so you can bring the whole thing outside. Same for this, can bring the whole thing outside. Here you're gonna have to factor. Do not bring this a outside by itself. No, you can't do that. Okay, this is a whole expression, just one expression in 3 different terms. Same thing for this one, factor it out. Same thing for this one. Let me go ahead and work out these two examples here. Let's work with this one here, and that's if I work it out as a by using the trial and error method. I know the first value is A. This sign is positive, therefore I'm gonna have either a negative and a negative sign, or a positive and a positive sign. That's the only thing that can make this sign positive. This middle sign tells me which signs to use, negatives. So I use negatives, and this is a square, perfect square, 25. The square root of 25 is 5, so 5 goes here. So this expression here is a perfect square. Okay, in case you didn't notice, it's difficult. Yeah, so it's a bit difficult to tell that this is a perfect square. Okay, but it is. So you can rewrite this as a minus 5 square. Okay, minus 5 square. Bring it outside the radical sign, the whole expression, this expression here. Alright, let's try that one there. Alright, so let me just fold this paper and let's work it out. Well, yeah, using trial and error is fine. If you don't know that these are perfect squares, you can tell, that's fine. Go ahead and use trial and error method or any other method, and you should be okay. X, I know those are gonna be my first terms. The only thing that can make this sign positive is either a positive, or a negative. This is what tells me which signs to use, two positives. This is a perfect square, so that's 1 times 1, that's 1. Yeah, so this is correct. Again, the whole thing is a perfect square. X, you can write it as x plus 1 square. Bring the whole thing outside the radicals, outside the radical sign, the whole expression. All right, so this is where I've noticed a lot of mistakes, because you go from working out problems like this, and all you're doing is just start factoring. However, I keep telling you that the first step needs to be, can you simplify? Can you simplify the expression first? Whenever you have more than one term in an expression, can you simplify it first by looking at all the terms and see if they have any factors in common? Okay, so in this case they do. See, the constants are have a let's see, no they don't. Let's see, 25, 5, nope, no, I guess they don't. Well, this one doesn't either. Well, I was gonna try to work one of those problems out, but I guess that's a fail. However, we can work this as with the AC method. Factor it out with the AC method, because we know that 4 times 25 is 100. Okay, let me see if I can work it out. And then we need two factors that make this up, that when added together give you a 20. So let's say 10 times 10. See, factors of 10 times 10, that's 100. And then we need this information here to split up the middle term. In this case, it doesn't make a difference here what the signs are, as long as you watch out for this sign, and when you split it up, you need to get this sign here. Okay, so I'm just rewriting this 4 a squared here, and then splitting up the middle sign there, which is which we said was going to be split up with these two factors here, except for now we're subtracting. Okay, we're going to have a negative 10a and a negative 10a. Rewrite the positive 25 here. Alright, so now we did that successfully because we because if we add these two together, that's gonna give us that negative 20a. Okay, so we haven't done anything really except for rewriting it differently. This is still the same as this, okay? Mathematically still correct. Alright, and now we can group. Okay, so the grouping is sometimes it's tricky whenever you have a negative sign here between the two terms. Okay, and I'm gonna show you one way of doing this. Okay, and if you can repeat this process again and again, that would be awesome. Close the parenthesis here. If you can think of always adding a positive sign between your factors here, well, not between your factors, between your parentheses, because these are not factors, because this is an addition. Okay, yeah, I got confused there. If you can add a positive sign here, always start there, rewrite everything. You can rewrite everything else as it is. Okay, if you add a positive sign here. If you add a negative sign, that's gonna change your signs over here too. So if you can start here, if you can remember that, whenever you use the AC method, whenever you split up the middle term and you group them by adding, okay, not subtracting. Later on, when you get good at it, you can start skipping a step and subtract. But for the first few times, if you can remember to add first and change the signs later, that's okay. Okay, so in this case I have I'm rewriting these two terms here, including the signs. Okay, to a plus 25. Alright, so now I have grouped these two, and now I can see that I can factor this out because these two terms have common factors. Okay, in this case the factor is going to be 2. The greatest common factor is going to be 2. Yep, 2 for the constants and a for the variables. Okay, because if I multiply 2a times 2a, I get 4a squared. If I multiply, just bring down the sign here. If I multiply 2a times 5, I get 10a. Okay, 2a times 5 times 95 gives me a negative 10a. Okay, and then for this one, I can see that I have common factors in the constants, and it's gonna be 5. So I'm gonna go ahead and I will write the positive sign. I'm just gonna bring out the constants, not the signs. Okay, so I'm leaving that positive sign there. It's fine. And I said the common factor was 5. Leave my negative sign there, it's fine. And then if I multiply 5 times 2a, I get negative 25a, negative 10a, negative 10a. Okay, 5 times negative 2a is negative 10a. Okay, rewrite your sign, and if I multiply 5 times 5, I get back 25. Okay, And then from here, I can see that these two factors, see, this is a factor, this is another factor. I can see that these two factors could possibly be factored out of this expression. See, this expression has two terms now. There's two terms, and I can see these two factors are almost common factors except for the signs. Okay, but I can see that this is the opposite sign of that. This is the opposite sign of that. So if I factor out a negative value, negative one, or a negative sign out of these two terms, and bring it outside, then that's going to make that a positive, and then this one negative. Okay, so that's what I'm going to do. Okay, if I bring out, if I factor out a negative 1 times positive 5 is negative 5, and then this stays as positive 2a, and this one changes into a negative 5, because if I multiply negative 5 times 2a, that's going to give me negative 10a. Okay, so yeah, we're still mathematically correct. If I multiply negative 5 times negative 5, that's going to give me a positive 25. So we are still mathematically correct. Okay, except for the signs look different now, which is what I wanted, because if I rewrite this side here, 2a minus 5, now I can see that these two factors are alike, therefore I can factor them out. So these are common factors to these two terms. Factor them out. Write them out first. That's what I would do. 2a minus 5. That's a factor. I'm done with these two. See, I cross them out so I can see that what I have left is this factor. Open up another parenthesis. Do not add a positive sign or a negative sign here, because remember, we are factoring out, so we should end up with two factors. Okay, let's do a minus 5. Here we added a sign, positive sign there, but that's because we are not factoring here. Okay. Here we did not include a positive sign because we were factoring. Okay, so that's the difference. That's the big difference. Oh, but now I can see that I have a perfect square here. Okay, so I can simplify that as 2a minus 5 squared. Okay, now I can see that I have a perfect square. Now I can pull it out of there because it has a power 2. So the answer should be 2a minus 5. Okay. All right. Well, I was trying to think if that I was going to be able to simplify some of this. Simplify them out first, and this one might simplify because I can see that. Well, maybe not. That's 18. No, maybe not. Oh well. Anyway, just make sure that whenever you see an expression with more than one term, either 2 or 3, either 2 like this or 3 like this, to simplify it by asking yourself, do they have any factors in common? If they do, like for example like this, then factor out those common factors. Okay, and you should have you should end up with 2 different factors. Okay, all right, and then keep going. If you can simplify it further, just keep going by factoring. Okay, all right, and that's it for section 4.1. okay, so let's move on to section 14.2, which is multiplying and simplifying with radical expressions. This is not as hard as it sounds, I don't think, because all it is the rule. Yeah, simplifying square roots of powers. To remember the rules of multiplying square roots and and the powers of square roots, which is basically the same rules for powers. Yeah. And so let's go ahead and start with objective A, simplifying by factoring. In this case, you have 2 square roots. You start with 2 square roots. Let me just focus here. In this case, you start with there 2 square roots, and you're multiplying them. So all it's showing here is the rule of multiplying square roots. So if you have 2 square roots that you're multiplying, multiply the radicands. That's all it is. Multiply the radicands, get the square root of it. Well, multiply the radicands, get the square root of it. That's all it is. Okay. See, because if you get the square root of 9, which is 3, and the square root of 4, which is 2, multiplying together, you get 6. If you multiply 9 times 4 and then get the square root of 36, you're still gonna get 6. Okay. So the rule is to multiply the radicands. See, if you have 2 square roots, you multiply the radicands. In case you didn't remember that, okay? And let's see if we can work out some examples here. Multiply, okay? Yeah, just think about this as being the same thing as this, multiplying together. Get the square root of that. In this case, it doesn't say to simplify, so just multiply it and don't simplify at the end there, because you can't. We don't have a square root for 35. It's gonna give you you're gonna get a decimal there, so you're not gonna get a perfect square there, a square root. So 8 times square root of 8 times square root of 8 is same thing as 8 times 8. Same thing here. Just write them together. Include the multiplication sign there. Multiply together and simplify if you can. See, because here square root of 64 is the square is 8. Okay. Okay, so here we have something different. It looks different, but still the rules are the same. You know, we know how to multiply terms, expressions with different terms. Yeah, the rule is to multiply every term with every term inside inside the parentheses. Well, the expression, yeah, inside the expression, inside the parentheses. That's you multiply this times this and this times that. Okay. Let me just get some water here real quick, because my mouth is drying up. Okay, so and then make sure you simplify the expression as much as you can. In this case, I don't have this. Well, no, this expression could factor out to x times 6x times 2x. So, well, let me show you what I mean. In this case, you could simplify it as that 6x squared minus 2x by factoring out common terms. I know that you can factor out 2x out of that, and then multiply that times 3x minus 1. That's gonna give you back this expression. Okay. However, it doesn't add anything. See, simplifying it this way doesn't add anything, because you cannot bring it outside the radical sign. See, this is not square. This is not square. So you cannot bring it outside the radical sign. That's why this is the simplified version of this. Okay, this is as much as you can simplify it. Make sure you do not bring this x squared outside, because it is included in the whole expression. Okay, don't make that mistake. All right, let's see what else. Expressions. Yeah, all of this is, they introduced that because sometimes we're gonna start with two expressions, and we need to multiply them to be able to simplify them. Okay, that's all they're doing, and I will explain that later. Okay, so yeah, think about the multiplication, multiplication rule of radicals in this way. In this case, 50, square root of 50 means the same thing as square root of 10 times 5. See, they found the factors, and the factors of 50, and then they left this. Let me see. Well, in this case, you can't simplify it any further. Just do this, but just remember that you can do this. You can find the factors and split it up. Yeah, because this means the same thing as this. Okay. Now notice here, we do the same thing. 25 times 2 is 50. You can rewrite it as this. However, see the difference here? Here we had a 10, square root of 10, and here we had a square root of 25. And 25 is a perfect square. Okay, that's why they use this version of square root of 50 instead of that one, because we want to get perfect squares inside the radical sign, so we can factor it out, so that this here will look something like square root of 5 square. Okay, and that's why you're able to move it outside the radical sign as 5. So the square root of 5 squared is 5. So that's this 5 here. Okay, so this you cannot simplify it any further, so just rewrite it, square root of 2 times, and this multiplication between the 5 and the radical sign. Okay, that's multiplication always. Multiplication. Okay, let's see what else. And think about this, because you're gonna remember that you will be working with expressions, and you need to get those expressions to look like perfect squares. If you can make those expressions look like perfect squares, just like this 25 is a perfect square, you are gonna be able to move it outside the radical sign. That's why they are introducing this section. Okay, let's see what else. And yeah, if you cannot think of a factor that is a perfect square, go ahead and find all the factors. It's okay. Go ahead and find all the factors, and then just group them together by 2's. See, and those are gonna be your perfect squares. Okay, so in this case here, 5 times 5 is the same thing as 5 squared, or 25. Yeah, which is that. And they basically got this from prime factorization, doing prime factorization and using all the factors. Okay, so you can do that too, because now you already know how to get all the factors of any value. So if you cannot remember, if there is a factor that is a perfect square, like this 25 here, don't worry about it. Go ahead and find all the factors first, and then group in groups of 2, and those are going to be your perfect squares. Okay, so you can, that's a trick, I guess, you could use. Okay, anyway, let's continue here and see if we can study that even further. See here, if you didn't know, let me fold my paper here. And if you didn't know that 9 was a perfect square and it was a factor of 18, we'll just go ahead and get all the factors of 18. Okay, that's 2. 18 divided by 2 is 9. 9 divided by 3 is 3. So all your factors are 2, 3, and 3. Okay, group in 2's, that should be your perfect square. Okay, so that's the same thing as that 18 has the factors of 2 times 3 squared. So that should be your perfect square, which is the same thing as 2 times 9. In case you didn't know that just by looking at it. Okay, go ahead and factor the whole thing out. It's fine. That's not a problem. And when I don't think you're gonna have that many big numbers, you know, to find the factors of, because all we want you to do here is practice. So you notice that here you only have 48 there. That's a pretty big number, but not too much. 20 there. 36. You can find the factors of those. Okay, so just in case you don't know what the perfect squares are, and if you want to know what some of the perfect squares are, well, just multiply two numbers together. Start with 1. 1 times 1 is 1. 1 times 1 is 1. 2 times 2 is 4. That's a perfect square. 3 times 3 is 9. That's a perfect square. And then just memorize them, you know, get familiar with them. It's fine. You don't have to memorize with this class if you don't want to, because if you do prime factorization, you are able to find these perfect squares. 4, 16. 4, yeah, 4 times 4 is 16. And then 5, yeah, 5. Yeah, no, so just multiply same values together, and those are gonna get you perfect squares. 8, and so on. Okay, and then you can just study them, you know, and so that's, yeah, 25 there, 36, 49. But now you're probably familiar with all these values. Okay, and if you can memorize those, that would make life easier. All right, or at least get familiar with them. Those are perfect squares. Okay. Okay, now it's a bit more difficult trying to see if the values they give you have a perfect square. See, because here, if I didn't know that I can multiply 3 times 16 and give me that, I think I would have struggled, you know, to tell that perfect square of 16 was a factor of 48. Okay. Maybe I would struggle with this one too. Maybe if I didn't know a 4 is a perfect square and is a factor of 20. But again, if you can tell that these values have perfect squares in them as factors, go ahead and find all the factors by using the method of prime factorization, and then group in twos, and those are going to be your perfect squares. Okay. And then if you have variables, well, just separate them by powers of 2. So like if they're even, like c to the 4th power, t to the 4th power. What was the rule for multiplying fractions? I mean for raising powers to other powers is multiplication. You multiply. So t squared to the 2nd power would be, see, since you multiply 2 times 4, that will give you this back. So you can think of this as being this thing here. And I think that's a lesson that we learned already, that we went over. And if you don't know that this means the same thing as this, think about the rules of exponents. If you raise an exponent to another exponent, you multiply. Okay, do not add, you multiply. And then that would be a perfect square. This right here. So separated by 2. That's what I'm trying to say. Because, well, in this case, you only have t squared. So t squared is a perfect square. Because now you have a power of 2. You can bring it outside because of this index of 2. Alright. And then leave the 5 inside because you only have one of those. See? So that one stays inside the radical sign. Alright. And bring out the rest of the values, well, the square roots of the rest of the values. So 2 here is the square root of 4. T here is the square root of 2. See, this is why I wanted you to learn that this base is the square root of t squared. Okay, so square root of t squared is t. Okay, bring it outside as multiplication. Okay, remember that the operations here between these values that you bring outside is multiplication also. Okay, that's important. Okay, let's move on. Well, now we have an expression. Again, if you can make it into a perfect square, that would be nice. If you can't, well, then you can simplify it. Alright, but you should always remember that you need to simplify to think about the different terms and see if they have any factors in common that you can factor out first and simplify first before you use any of the methods. Okay, I know I'm repeating that, but that's very important. Okay, so in this case they went like well, I mean, if you don't know that this is a perfect, you can tell that this is a perfect square, that's fine. You know, I've been telling you that you don't have to. You can find that out by using trial and error. First values is the square root of x squared, so x. For the signs, I need 2 signs that are going to give me the positive sign at the end. So it's either a negative and negative, a positive and a positive. This sign tells which negative signs. We use negative signs. For the second terms, I'm going to use the square root of the last term, which in this case will be 3, because 3 squared is a perfect square. So 3 is here, and so this is a perfect square. And you don't have to know that, okay? You don't have to be able to tell that from here, but if you can, that would be nice. Just make sure you solve with trial and error, the trial and error method. You should be okay. So now you have x minus 3 squared. That's a perfect square. Bring it outside. Bring outside the radical sign. Okay, like that. All right. Here we only have one term. I know that this one is a perfect square because of that power 2. I can bring that one outside right away, and that would be this here, x. If you didn't know that this 36 was a perfect square, go ahead and factor it out, and you see that. Well, I'll tell you what. Let me go ahead and do that myself right here, because this is one way of thinking about going about getting perfect squares. If I divide by 2, that's 18. If I divide by 2, that's 9. If I divide by 3, that's 3. Okay, so in this case I have 2 squares. If I combine them together, that's 2 square times 3 square. Okay. Now I have 2 square. Well, once I factor them out, I know that I can bring this outside as 2 times 3. 2 times 3, which is 6. So in case you didn't know that this was a perfect square, go ahead and factor it out. You should still get the right answer. Okay. It doesn't make a difference to me how you do it, as long as you do it. As long as you do it correct, it's okay. Okay, so here again, the first question should be, since this expression has more than one term, can I simplify it by factoring out? Let me fold this paper here. By factoring out common factors to all those terms. Alright, and the answer is yes, because I know I can factor out at 3. Let me bring this down a little bit. Yeah, I know I can factor out at 3 there, out of there, and that would give me an x inside the parentheses, and 2x here, and a 1 here. Okay, because if I multiply 3 times x squared, that's gonna give me that. If I multiply this times this, it's gonna give me that, and 3 times this is gonna give me that. All right, so now I have this simplified version of this expression. Now let me see if I can work it out by trial and error. Let's say I didn't know this was a perfect square. Okay. For the first values, you use the square root of x squared, or the first term, so x. For the signs, use 2 signs that are going to give you a positive at the end, either negative or positive. This sign tells you which, positive and a positive. And then for the second terms, you use the square root of the last term, which is 1. 1 square is 1. So the square root of 1 square is 1. Alright, and notice that this is a perfect square. Rewrite it as x plus 1 square. And notice that I didn't think of this as being a perfect square, even though it was. So and the only times you're gonna get a perfect square is when you have 2 signs. Well, not 2 signs, not signs. Well, the opposite sign here. Yeah, a positive sign here. You might be able to have a perfect square is if you have a positive sign here and either a positive or negative sign here. Okay, positive here, always a positive here. You should always have a positive here, because that's what's gonna make these 2 signs be equal to each other. Okay, be the same. This positive sign. Okay, if you have a negative sign here, no, you just, there's no way you can get a perfect square. Yeah, that's one way of thinking about it, of going about it. But if you cannot think that this is a perfect square, go ahead and simplify, well, factor it out by trial and error. It's fine. It's still gonna give you the same answer, okay, just like I did here. All right. So where were we? Yeah, and that's a perfect square. Now you should be able to bring it outside the radical sign. Yep, taking the square root. Radicals, square root. Yeah. Yeah, take the square root of that, and yeah, you're done. All right, there's nothing else there that we need to go over. So we need to move on to, and I'm gonna move on to section B because we can practice some of these problems in class. If there are any variations, we can practice those in class. All right, so we're moving on to section B because this is also an important section because we're going to be working with expressions inside the radical sign and powers. Okay, so for example, this expression here, in other words, x, the square root of x to the positive 10, that would be the same thing as x squared times x squared times x squared times x squared 5 times, right? Because you have like bases and you're multiplying, so just add the exponents. And if you do that and you bring them outside the radical sign, you're going to end up with x times x times x times x times x. In other words, x 5 times, or x to the 5th power, okay? Which is what they did here. They just turned this x to the positive 10 into an x to the 5th power raised to the 2nd power. Because remember the rule for exponents, for raising exponents to other exponents, it's multiplication. So 5 times 2 is 10. Okay, so whenever you have even numbers, and you should be able to get them in powers of 2 and not get any remainders. Okay, in this case you're going to have exactly 5 pairs of x times x, 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 5 of those, which is what they're telling you here. X to the 5th raised to the 2nd power. That's important because if you have odd exponents, then you're gonna have a remainder of one remaining, one variable remaining, always, but not when you have even exponents. Okay. All right. So let's go and work with even exponents first, and then we worry about odd exponents. Okay, so here x to the 6th power, you can think of it as 3 to the 2nd power. Okay, and then here x to the 8th is, think of it as being the same thing as x to the 4th raised to the 2nd power. Okay, and that's why we were able to bring it outside the radical sign. Okay, because we raised to the power 2. Let's do this one too. This t to the 22nd, you can think of it as being t to the 11th power squared. See, because if you multiply 2 times 11, that's 22. That's this power here. Okay, so you haven't done anything to it except for rewriting it a different way. Okay, and let me see. Oh yeah, notice now the pattern there. Notice how hold on, let me bring that there. Notice how if we write it with an exponent of 2, raised to an exponent of 2, that version there. And this version here, raised to the power 2, raised to the power 2, raised to the power 2. Well, notice the pattern there. 10 is halved here. 6 is halved here. 8 is halved here. And 22 is halved over here. So that's a shortcut right there. So again, if you have even exponents, just half it and write it as exponent of 2. Okay, half it. If it is even, half it and raise it to power 2. If it is even, half it, raise it to a power 2. If it's even, half it, raise it to a power 2. If it's even, half it, raise it to a power 2. That's the pattern there. Okay, if you have even exponents. Okay, that's it. That's the rule for whenever you have even exponents. Now what happens when you have odd exponents? Well, it's similar. You could think of it as similar, except for you're gonna have again one variable remaining always, because, and let me rewrite it here, because if I start here. If I factor that out, if I factor x to the 9th, I'm gonna end up with x times 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 x. 1, 2, 3, 4, 5, 6, 7, 8 times x. Group them in 2's. Oops. See, I'm always gonna have a variable remaining. Always, if I have an odd number as an exponent, this can be rewritten as x squared, x times x squared times x squared times x squared times x. So there is the variable remaining I was talking about. Okay, when you have odd exponents, x to the 9th, the same. X to the 9th is the same thing as this, with one x remaining. Okay, so since I know that, and that's going to happen every single time, I might as well just write it without it, write this exponent without that remainder, that variable, and I just I know it's going to stay inside the radical, so I might as well write it that way. And then, since I already know that all I have to do whenever I have even exponents is half it, raised to the power 2, that's what I'm going to do. X, so I'm rewriting it as x to the 4th to the power 2. 2 times 4 is 8. That's the same thing as this. Now I can move this x to the 4th outside the radical sign, which is what I did here. Okay, so that's the process there. If you have an odd number as an exponent, just set one of those variables aside, just one of them, rewrite your exponent, and now you're going to end up with an even number, an even power. Okay, and now we know that if we have an even power, just half it and square it, bring it outside, and that should be your answer. Okay, again, and I would start with my variables. It's easier to work with, because I can see that I have an odd exponent here, so I'm just gonna leave one of those variables outside, just put them aside. That's gonna stay inside the radical sign in the end. See, rewrite the exponent as x to the 14th and half it, square it. That's 7 squared, so that's where you get your x to the 7th. For the variables, the constants, you don't have to know that 16 is a factor. 16 being a perfect square is a factor of 36. You don't have to know that. If you can remember, that's fine. If you can tell, that's fine. As long as you factor out that 32 completely. Let me just go ahead and write it out again. Different example, another example. That's 16 divided by 2 is 8. 16 divided by 2 is 4. 10 divided by 2 is 2. So those are all my factors of 32. Group them in 2's. I can rewrite that as 2 squared times 2 squared times 2. Okay. Notice that I have a remainder there. That's going to stay inside the radical sign. Bring out this 2 to the power 2 outside by multiplying 2 times 2. 2 times 2 is 4. So that 4 should go outside the radical sign. Okay. And that remainder, the 2 that remain there, that stays inside. Okay. And notice that I did this by factoring the whole thing out. The whole number 32. I didn't have to know that 16 was a factor of 36. I mean of 32. And that's okay, as long as you can factor the whole number, the whole thing, and then group in 2's, and then just bring them outside by multiplying. Bring them outside and multiply them. Bring them outside and multiply them, and you should get the right answer. Okay. And we won't practice any of those here because this lesson is getting long already. So let's go ahead and move on to section C, or objective C, multiplying and simplifying. Okay, so this is basically the same thing as we've been practicing, except for they give us more complex problems, but that's okay. So let's go ahead and try some of this. I'm going over some of this. So let's go ahead and work on this one. Example 16, multiply and then simplify by factoring. Multiply and then simplify by factoring. Okay, so here they are introducing something we can do to expressions. Okay, except for they give it to us in the form of constants here. Because notice that whenever you have two radicals that you're multiplying like this, it is not easy to see that you can simplify them, and you can't. You actually can't, because the factors of 2 is only 2, so you can't factor it out. You can get the square root of 2. You're not gonna get an even square root. So you can't factor that. But what about square root of 14? Can you simplify that? Let me see. If I divide 14 times 2, 14 by 2, that's going to be 7. These are all your factors. These are all the factors of 14. So now you cannot group in groups of 2, so because these are different. So now you cannot simplify this any further. Not in this form anyway. And that's why you need to multiply together like this. Okay, so that's why you need to think of this as being the same thing as this. Okay, because if you multiply together now, 14 times 14, well, in this case you don't have to multiply, because 2 is going to be a factor of the whole thing. Okay, 2 is going to be one of these factors. 14 has this factor and this factor, so just I'm in here. So you multiply 2 times 2 times 2 times 7. Okay. Now you can group these two. See, you can rewrite that as 2 squared times 7. Okay. This is the same thing as this. Okay. But now you have a perfect square here that you can bring out of the radical sign. Okay. This 7 stays inside because it doesn't have a pair. So anyway, yeah. So that's what they did here. And they bring out the 2 square, and your answer should be 2 times the square root. Yeah, the operation there is multiplication. 2 times the square root of 7. Alright, and that was an example of multiplying fractions, multiplying radicals with constants. Now they are introducing expressions. These expressions are in one term. Okay, so that should be easy, I think. Anyway, you can still simplify this, but the answer will look different. Let me go ahead and simplify for you because I believe it's important. You could simplify them separately. Bring out this x squared. That will look something like, something like x times square root of 3 and times 3. Well, let me go ahead and write this multiplications operation there. It's 3 times x times the square root of x. Okay. Because you can bring out an x out of there, and at 3, because 3 squared is 9, so that's a perfect square. That's why I can bring out a 3 of the inside from inside the radical sign. So this is the simplified version if you do not multiply. Okay, so notice that it looks different. It looks different from here. Okay, however, you could still simplify this even further by multiplying together, or you can multiply here. See, if you multiply this times this, multiply the whatever's outside the radical sign together, that's 3x. Those are like terms, so multiply 3x. This times this gives you this 3x squared, and then the rule for multiplying square roots, just multiply the whatever's inside, the radicands together. That's 3x. Well, in this case we can't combine, just rewrite them together, and that should be your simplified version, which is the answer they have, except for they multiply together here first. Okay, you can do it that way too, it's fine. What did they do? They did exactly the same thing we did, except for they did inside the radical sign. Okay, let's see if they have a different scenario here, because that wasn't much different from the way we did it to the way they did it. So let's see here. Let's see. They have 20. Well, they do exactly the same thing we did, except for they multiply together first, and then get all the factors, group them together in twos, which is what I've been saying. Group them together in twos. They have to be factors though. Okay, group them together in twos. If you can't group them together, they're gonna stay inside they're going to stay inside the radical sign like this. Okay, bring them outside and multiply them. Multiply them, you get this. Okay, and that's it. Let's see what else. Here they they're telling us the same thing I told you before. Do not think of this expression as being the same thing as this. Do not bring out one of the terms or separate them. No, that's an addition there. It's not a multiplication. Okay, so that would be a mistake. Anyway, I think we're done, and that's the end of that lesson. If you have any questions, make sure you ask them in class, and I will see you in the next video. Okay.